Welcome to Building Research Relevance. My name is Stephen Shaw. I'm the Department Chair for Educational and Counseling Psychology at McGill University. Today in Building Research Relevance, I'm going to talk a little bit about open science. We hear a lot about this. This is a big thing, and everyone kind of thinks open science is like, social justice and other things. It's just good. Well, it's more of a movement than a set of practices. But ultimately, what open science is about is improving transparency and credibility. And I find this, it's really important if we're going to have relevant research that it's transparent and credible. That just makes sense. From my perspective, open science is science. The more traditional or less open science is really secret science, which isn't science at all. It's academics playing games with academic incentive structures. Opaque science involves a lot of trust me. We have these method sections that are very, very short. We really don't know how data were collected, how they were analyzed. It's just to try to fit into the brief page limits available on many journals. And so we just say, trust me, I collected these data right. I analyzed them right. Here's my answers. Here's my fanciful conclusions. And the truth is, I don't want to be too mean, but I don't trust you. That's just how it is. I want to see your data. I want to see how you collected it and see how those data, yes, I do say those data, how those data are converted and analyzed and lead you to the conclusions you have. So, yeah, the fact is I don't trust people, and I don't think anyone else does either. I'm one of those people, just like the, now I forget his name, but the scholar who was an editor of a journal in biology, who, when he asked people to send him the data, found that very, very few people sent him the data. For me as a journal editor, I did this, not regularly, but I did this on 3 occasions where the data looked just too good. In real life, we don't have that. Because it wasn't an open science process, I don't know where the data came from. So I asked for the data just to do a quick reanalysis. I wasn't planning on doing anything, horrible or anything evil. I wasn't looking for a problem. I just wanted to see the data because it's pretty cool when you have data that come out that sweet. But what happened was, in all 3 cases that I asked, they withdrew the paper instead of sending me the data. I think every editor has come across something like this. The result is we got to start with open science. And what does that mean? It means a lot of different things to different people. But it's very much like reproducibility. That's a thing right now. It's important. Not everything, but open science, reproducibility are important. Ultimately, the open science talks a lot about FAIR principles, FAIR. This is an acronym where it's FAIR is findable, where research outputs are discoverable by this larger academic community and the public. So people can go in and find your stuff. Accessible, using unique identifiers, metadata, clear use of language, clear use of methodological protocols. Should be interoperable, so standards to enclose and exchange data and metadata are clear. Should be reusable, so they can repurpose research outputs to maximize their potential. So those are the gross principles. And so what we're really talking about here is making your stuff accessible, transparent, and ultimately credible. And there's a lot of different specific elements of open science, and we can just agree or not as to what actually counts as open science. But I think if we're going to move this towards a credible, relevant science, we need to engage in a lot of these activities so people know exactly where they have the data. Because right now, nobody trusts experts, and that's what we are. Don't blame them, but we should be able to put our information out there. We become experts simply because we're really good at this, not because we're an expert so you should believe what we say. We're an expert so we can put data together. We have to remember that a lot of the global warming data are fully available to everyone. You can access global warming data, but there are people who are motivated not to believe it, so they just dismiss it, when in fact they could go in and reanalyze the data themselves and come up with maybe different conclusions. I don't think that's what would happen, but those data are fully available. So I'm not saying that we're going to change everyone's mind or fully engage in trust when we engage in open science practices, but it's a start, and it's a start that's necessary. Here's just some of the elements of some of the things that apply for open science. One that I really like is the use of preprints. Preprints have many valuable things, valuable components to them. One of the most important parts of a preprint is that it is universally available. There's not a paywall. There's not something that's going to make somebody else a lot of money as you provide free labor. In fact, it's fully available. And yes, it does go past a pre-publication peer review. It can receive a post-publication peer review, which doesn't happen that often except on papers that get a lot of attention. But honestly, given the nature of what peer review supplies, I don't think we're losing very much by not having a peer review. But preprints are a very valuable way to make information fully available. Registered reports, I've written a lot about that and engaged in some registered reports. I think they're very useful. This pre-registration, usually a registered report is something that a journal does, but pre-registration is something that anyone can do on any study. And this pretty much gets rid of the hypothesis after results are known, also known as harking. It gets rid of that as a major factor, because what it does is you say what your criteria are, what your research questions, what your hypotheses are in advance, how you're going to measure those, how you're going to develop modeling or statistical tests to demonstrate evidence or non-evidence for those hypotheses. And then at that point, then you can just find the data. You can focus fully on collecting data in a right, appropriate, and accurate manner. You don't have to worry about something's significant or not significant in a registered report. But even pre-registration puts a timestamp on your research questions and hypotheses so that you know when you collect the data later, you go back to the research questions and they're fair tests. The other component of this is open data. I would like to see data sets fully transparent and open. I think we need maybe a little bit better rules concerning data sets in terms of if I collect a large data set, which is a massive and expensive undertaking, I don't want to put it out there and have somebody else just pick like vultures at my data set. However, people should be able to reanalyze it, should be able to answer new questions with a data set. But I think the original data set provider should receive at least authorship on all of those, because that's where the original data come from. I think we could work on that, but open data is really important. Open measurement equally is important. How did you come up with those data? What was the mechanism by which it worked? Was it direct observation, checklists, surveys, whatever it is? Even if it's more experimental data or lab data, you need that measurement to be described. You need those measures to be fully available if possible. Published instruments do have some issues because you can't put those fully online because that would violate copyright. But people need to know fully what the measures were used to collect data. There's also computational transparency. There's some really cool papers giving a complex data set to different labs, having them do the analysis and find out that almost everybody did their analysis differently. We need to appreciate that there are multiple ways to analyze data, especially if you're using fairly complex models. Multiple ways do not mean one's better than another, but there are strengths and weaknesses to each approach. Being fully transparent on how data were analyzed, how they were modeled, are really important. Of course, a lot of this issue of computational transparency would be less important if we had really strong theories behind it. And then the theories would lead to research questions, which would lead to specific types of analysis. But that would only reduce some of the problem. There's always going to be problems of different people having different, pet analyses, and that does happen. So computational transparency, exactly what was the algorithm that you used in your model or in your analysis? Other components are things like citizen science, to make evidence, your papers, your data, your measurement, your computations, fully transparent so anyone can look at it and question it, challenge the methodological grounds of what you do. Perfectly acceptable and actually a good thing. Skepticism, and I don't mean fake skepticism like vaccine skeptics. They're not skeptical. They're ignoring reality. But true skepticism from citizen science can really keep us on our toes and help us be accurate with what we do. So citizen science also fits into open science, as well as just research integrity. I hate to say that we have to have a specific protocol in which we conduct and report science in order to maintain research integrity, but it's no longer enough to say we are true gentle people of science. We're gentlemen and gentlewomen of science. Therefore, what we do has full integrity because trust us. That's not enough. I hate to say it. Like I mentioned earlier, I don't trust you. I've seen enough. I've seen too much of this area where we know that multiple, more than 10%, as many as probably 1 in 7, I would say higher, when we look at data, are actually fraudulent, either fully made up or definitely manipulated. That's 1 in 7 for that. There's probably at least twice that many that are just careless or made errors that are not fraudulent, not made up, not evil, but just errors. So we're probably talking 35-40% of papers. The result is research integrity is a key part. We need to be as transparent, as open as possible. So open science kind of is this movement, and it's not everything. If we fully operationalize all these open science principles and others, we might improve the quality of scientific research by, 5%. But that's a lot. I think there's a lot of things that have to be done for massive research reform for us to gain full relevance, which includes credibility. But the mindset of community science and transparency leads to increased credibility and increased relevance. And there are critics of the open science movement. A lot of it is stylistic. People don't like the, slavish cultism that open science is good. I get that, but that doesn't bother me too much. I just think it will improve things a little bit. I still think we have a lot of other things to work on that we'll talk about in other sessions. But the critics of the movement are mostly of the mindset that this traditional, or I'm just going to call it opaque science, it's worked for them, so why should they change things? That method is the kind of trust me mentality has worked. They've been very, very successful. They're not going to change things. They're not going to develop new ideas. They just want to do the same old thing. And some people who promote more exploratory research or qualitative research, those folks tend not to be especially supportive of open science practices. But I would make the case that open science practices can be a godsend for improving the relevance of exploratory research and of qualitative research. We forget that. There's nothing wrong with qualitative research, and open science can have a lot of positive effects for that. You do have to change some of the issues of informed consent if you're going to share data. But those are not insurmountable. There's actually papers out there and protocols out there of how to adjust your informed consent forms to include shared data. So I'm not really terribly worried about it. But I do think that open science principles are going to be key. But I think if we consider that science needs to be a community effort, it's not by a bunch of people who should just be universally trusted. Because I think the pretty good evidence, and I know there's anti-science people out there, I'm not one of them, but I think there's pretty good evidence that the just trust me is not a particularly good method of having research both transparent, incredible, and for purposes of my little series of talks here, you can't have relevant research that is opaque, hidden, and relies on just trust me. Relevant research has to be transparent. So thanks very much, and we'll talk again at the next session of Building Research Relevance. Thank you.